Hi, Assalamualaikum. My name is Rasul Reza Zaharuddin. Kat matrix number 10BKN 34M1016. Today I'm going to talk about introduction. Our nation, Malaysia, is committed to a transformational journey under the Malaysia Green Technology Master Plan and the US Sustainable Development Goals (SDGs), aiming for a low-carbon, sustainable economy by 2030. But this ambition faced a monumental challenge, particularly in industrial sector. Malaysia, as a global manufacturing hub, especially in electronics, is generating a towering volume of scheduled waste, specifically electronic waste or e-waste. Right, first of all, I'm going to talk about technology and infrastructure hurdles. High capital investment for advanced technology, establishing hydrometallurgy facilities requires massive initial investment in specialized equipment, chemical handling system, and advanced wastewater treatment plants, which is often prohibitive for small and medium enterprise (SMEs). Next, lack of domestic technical expertise. There's a scarcity of Malaysian engineers and technicians formally trained in operating, maintaining, and optimizing complex high-tech recovery processes like hydrometallurgy. And absence of standardized DFD mandates. Unlike some development economies, Malaysia lacks a robust regulatory framework that mandates the implementation of design disassembly (DFD) principle during product design, slowing its adoption. Immature law integration. The overall industry's ecosystem has varying level of digitalization, making the nationwide implement of a comprehensive smart logistic and lot traceability system difficult and inconsistent.
Moving on next to the economic and policy barrier. Cost competition with informal recycling. License, formal recycler using sustainable method cannot compete on cost with the informal, often illegal, sector that avoids environmental compliance costs and offer high price for a scrap e-waste. Fluctuating global commodity prices. The profitability of recovering precious metal via hydrometallurgy is highly susceptible to the volatility of global metal market, creating financial risk and discouraging long-term investment. Next, inadequate extended producer responsibility (EPR) SIM. Current EPR policies often do not provide sufficient financial incentive or regulatory pressure on manufacturers to fully integrate DFD and reverse logistics into their core business model. Last but not least, limited access to financing for green projects. Despite government initiative, obtaining bank financing or venture capital for specialized green technology projects is often challenging due to the perceived high risk and long return on investment period.
Next is supply chain and operational friction. Complexity of disassemble and material separation. E-waste streams are highly heterogeneous. Disassembling order. Non-DFD compliant product is costly, labor intensive, and time consuming, hindering efficient material sorting for advanced recovery. Inconsistent e-waste collection volume, feedstock. The lack of an efficient, centralized collection system leads to an unpredictable supply of feedstock for hydrometallurgy plants, preventing them from achieving the necessary economy of scale to be profitable. Regulatory fragmentation and enforcement. Although e-waste is skilled waste, the enforcement of regulation across all states and industries can be inconsistent, allowing non-compliant practice to persist and undermine formal efforts. Transboundary movement, illegal imports or exports. Malaysia continues to battle illegal importation of e-waste from other countries, overwhelming domestic processing capacity and further complicating the management of the waste stream.
For conclusion, as engineer, our responsibility is to build the future. By integrating this scalable, sustainable solution, Malaysia can not only mitigate environmental and health risks, but also unlock a new multi-billion-dollar domestic industry centered on resource recovery.